Hey, what's going on, everybody? Isaac here with Civil Engineering Academy. I just wanted to jump on real quick and introduce our next episode, which is actually a really fun one that I did. I learned a lot because we were talking to international professional engineers. I specifically talked to Noah and Mostafa, who are with structuralengineeringbasics.com. And we have a special deal for those that are interested. If you go to structuralengineeringbasics.com/CEA, you can go learn about some of the courses that they're producing. I think they're really fascinating on helping people learn about the basics of structural engineering if you want to learn more. Obviously, hopefully you took some in school, but if you want to learn more, this is for everybody and anybody. So there's good stuff. Anyway, we talk about a lot of different things, how you become a professional engineer in Canada, how you become a professional engineer in Egypt. There's just a lot of good stuff in here, a lot of tips and a lot of fun things that we talk about related to that. So anyway, with that introduction, it's going to be a fun one, and we'll get right to the interview. All right. Welcome, everybody. We're excited for another fun episode of our Civil Engineering Academy podcast. I've got two great guests with me today. We've got Noah on. How's Noah doing?
Doing great.
Doing great. And I got Mostafa as well. How's Mostafa?
Doing awesome. Thanks for having us.
Yes, we're very excited. I guess as we begin, why don't we start with Noah? Where are you from, and how did you get into civil engineering? We want to know that.
I am a professional structural engineer in Winnipeg, Manitoba, Canada. So that's in central Canada. And how did I get into civil engineering? For me, it wasn't as easy of a path as other people. To me, it was actually I did the first year of university and I was struggling. I just took a whole bunch of different courses, science, business. And I pretty much said to myself, what don't I want to do? So I cut out a whole bunch of things, and then I ended up in engineering. And I knew I wanted to do engineering, something like that. But then it even took me another year to figure out what sort of discipline. But when I looked at civil engineering and saw how many options there were and how broad it was, and I still could have 4 more years of studying to figure out exactly what I wanted to do. And when it comes to mechanical or electrical, it's broad, but I think civil engineering is, you have the most opportunities. So that's sort of why I chose that. I didn't really have anyone in my family or around me who had experience in civil engineering. I didn't have many connections, so it was sort of a tougher path, but it's one that I'm glad I took.
Awesome. That's good to know. So you're in the structural engineering field right now, and you practice as a structural engineer where you're at. Cool. Yeah. All right, Mostafa, let's talk about, how did you get into this, and what are you doing now?
That's a great question. For me, I've always had this interest and passion for buildings and tall buildings. And I was really fortunate after I graduated. I finished my undergrad in structural engineering. I got a chance to work in Dubai. That was back in 2005. And now they have the tallest building in the world. So I got a chance to get a firsthand experience in what goes into the consulting side of designing and building tall buildings and tall structures.
Wow.
And after I went through this experience, I realized wow, there is a lot that you actually need to know and learn to be good in structural engineering. So I decided to go back to school to do my master's, and eventually I decided to move to Canada. I'm originally from Egypt. This is where I did my undergrad, and I decided to move to Canada to do my PhD. And eventually I ended up teaching at university and getting my professional engineering license. And actually, Noah and I, we work together in the same consulting firm. So yeah, it has been a great journey.
Wow. So on your side, Mostafa, did you have any family members or anything? Like when you first started going to school, what was the drive to just jump into engineering? Is that just something you wanted to do?
Yeah, that's a very interesting question. My father actually is a structural engineer, and I went to the same school that he went to. And I remember growing up, watching him, or listening to him, on the phone talking about a project I was very curious, like, talking about foundations, cantilevers, beams. I wanted to know what all these things are about. And when it was time to choose, I thought, well, you know what? I think engineering might be a good choice. And I ended up loving it. I think I'm very fortunate that what I chose ended up being really connected with what I'm passionate about and interested in doing.
That's awesome. And you're in Egypt right now, right?
I am.
Okay. And you still have a place in Canada, is that right? Or
Uh, yes, yes.
yes.
So I just very recently made that transition, moved back to Cairo, and what I'm doing now, the school term is starting soon. I'm teaching engineering at university, so I'm busy
Great.
preparing lecture notes and getting things started. So looking
That's
forward
awesome.
to that.
Well,
Yeah.
that's great. That's a fun journey for both of you. That's really great to hear that. I want to ask, you guys, we got Canada, we got Egypt here. How do you become a professional engineer in those countries? Like, what are the requirements? What's the path to licensure there?
So yeah, I can start for Canada. And actually in Canada, they leave it up to each province to sort of delegate what the requirements are. So I'm in Manitoba. We have engineers and geoscientists of Manitoba. That's the association, the governing association that you have to get your designation from. So for Manitoba, and it's similar province to province, but there definitely are their differences. You have to get your undergrad degree. There is something called civil engineering technician. I'm not sure if they have those in the States, but
I haven't heard that.
it's taking a similar path, but you can't become a professional engineer, like a licensed professional engineer if you go with that path. You can do a lot of similar things, but you can never have your stamp and, seal a drawing.
Do
So
they
if
have
you
like reciprocity? Can you move between provinces, or do you have to do separate?
you have to apply to get the designation and get your stamp in each province. So
Okay.
I'm not sure if you have to go through everything, all the requirements. Maybe once you have it in one province, it's easier to get in different provinces.
That's really interesting.
Back to the schooling. So you have the 4 years. Usually that's what the undergrad is, 4 or 5 years. Mine was a 5-year program. Once you have that, it's not like the States. There are no big exams. We have 2 exams along the way. One is called the ABC test or exam, and that's on like the code of ethics for the Manitoba Association of Engineers, EGM. And then the second one is, I think it's more broad. It's offered in multiple provinces, called the professional practice exam. So it's not technical at all, but it's on ethics and it's on law, like construction law, engineering law. So those are the 2 tests you got to study for, but it's not anything near what I hear it's like in the States. So when you have the 6-8 hour exams and studying nonstop while you're
Yeah, there's a lot of that going on. So
yeah.
I'm curious,
So
like, is there a lot of weight to being a professional engineer then in the country? Like, is it
I
looked
think
at?
they, if you have your seal, you're taking responsibility. And I
Yeah.
mean, there's a lot of responsibility when you issue drawings and, if something happens, especially if it's part of your design, if something, if there's a failure, if people get hurt, there's a lot of responsibility. So I think that weighs this profession pretty high compared to some other ones.
I
And back
agree.
to getting your designation here, what we do differently instead of exams, it's work experience. So it's work experience and reports. So every 6 months for 4 years, you have to write a report. You have to get a mentor or a senior at your company to sign off on the report, to review it. And it actually goes to like a experience review committee. And they'll
Wow.
give you comments after every report saying, okay, yes, you're on the right track. This is okay. Or they'll give you recommendations. And after the 4 years of experience, you need 3 mentors or 3 references pretty much. And they have to write a report on you. You still have to do one final report. And then they have to write something to the association and like a letter of recommendation, or it could be a reason why they don't think you should get your seal right then. So
Wow.
it's 4 years, but they put a lot of onus into getting your professional, it's called PEng in Canada, professional engineering designation. They put a lot of onus on your mentors, the seniors, the people who have watched you do the work at their company, to let the association and the public know that this person is ready to do the job and take responsibility on their own for their project.
Wow, that's really interesting. I know in the States, we do also have to track projects that we've worked on, and you do have to work under a licensed professional engineer in order for that to qualify, because they have to sign off on you. But it sounds like yours is kind of a step above that. That's really a big deal. So,
They also make us actually do like on top of like the work experience, they have to, or we have to do volunteering work. You have to do
wow.
attend conferences, and you have to track all these hours. You have to track, and they have a review committee that looks to make sure you're actually doing the volunteering and you're doing like outside extracurricular work. And then even once we get our designation, every 3 years, like sort of a running 3-year thing where you need to have 250 hours of extracurricular work.
Holy
And they
cow.
break it down, and we break it down into formal activity, which is like seminars, informal, which could be like attending a workshop or reading a manual. So you can do it at your work, and I guess you can claim it. Participation, so that's like being on a board, volunteering on a board, judging a science fair. I've done that.
Sure.
Yeah,
Well,
being
that's
on
really
it,
interesting.
or giving presentations, stuff like that.
That's awesome. Well, not to switch gears, but let's hear about Mostafa. Like, I'm assuming you've got your professional engineering license in Canada. Is that right?
Yes, that's true.
Do
And
you also have
it's
it in Egypt or in other places? Like, how does?
so I mainly have it in Canada, and
Mhm.
I was looked into like the trying to compare the process in Egypt, and it seems it's like weighing more on years of experience. So after you graduate, there isn't a lot of exams you need to do, like you consider it as like the academic qualification is going to be sufficient for you to start working as like an engineer in training under supervision of like a professional engineer. And it takes much longer to be able to apply for the full license. I think they call it like a consultant professional engineer. And it takes about 15 years, like in order to be able to get that full stage, kind of be able to seal joints on your own. It takes that much time and building, your career and the projects that you've worked on under supervision of professional engineers. So the way it works is usually by the time you've been working that much in the industry, it's either like your partner in the office or you have your own office and you have like junior engineers and you're mentoring a whole bunch of engineers, and then the full licensed professional engineers responsible for the actual stamp seal of the project, of the drawing. And of course all the engineers in training, they're responsible as well, but they kind of report to the person who's comfortable with stamping and sealing the project. So it's a little bit different. It just like weighs heavily on like years of experience, not a lot of sit down like written exams. There is like a committee that you will have to present the body of work that you've worked on to demonstrate that you've worked on significant projects to kind of finalize that final stage.
Do you feel like that's the biggest challenge in getting the license? Is it the experience, or is it something else? Is it the committee? Like, what do you feel like is the biggest challenge in getting the license there?
I think it's the relevant engineering work, like obviously the time, like you need to be looking at it as like long term, like this is really what I want to be doing. I see myself like in this career and maybe starting my own office or something like that, not just like working in a big consulting company and just like doing modeling or doing analysis here and there. So I think that's definitely one of the challenges is that it's just like how long it takes to be able to stamp your own projects. But at the same time, my experience in working in Egypt has been in like a very large firm,
Mm.
working on like very big projects, tall buildings and things like that. So it has always been like a big team working on the project, and each group leader or each engineer would be, of course, responsible for the work they do. But eventually, like the engineer of record or like the professional that is going to put their name and stamp on it is going to have to make sure that everyone is comfortable with the work they've done, and they're like professionally responsible for it. So
Mm.
yeah, I think it's a long process.
So and I might have missed this, but what's the time frame then? What's the time frame it takes to get a professional engineering license there? What is
So
that time frame?
there are a few stages. For the full final stage, it takes 15 years of work experience.
Wow,
So they're
that's a
pretty
lot.
heavy on like, yeah, you need to be
Holy
like
cow.
committed, dedicated, like I'm gonna keep on doing this until I get that license.
That's awesome. And then
Yeah.
Noah in Canada, what did you say was the time frame to get the license with gathering all your experience?
I said 4 years. 4 years
4 years.
after. Yeah.
Okay. Wow. So in the States, it really depends on which state you're in. They have different requirements, but usually the max amount of time is a 4 years after you've been out of school, working under a professional engineer to get your license, to get that designation. There also are states that allow 2 years of experience to get that license. And there are states that require additional stuff, like California does additional testing on top of the test that everyone has to take. California does their own little thing, and they do additional testing to test you on seismic as well as surveying. So you have to do additional exams on top of that. But wow, there's a whole different flavor there for experience and the time it takes to get a professional engineering license. I'm curious, like if I'm from the United States, if I came to Canada or I went to Egypt, does any of the stuff I've worked on here count? Or do you have to start over, you think?
You definitely don't have to start over. I
Okay.
know that there's applications you can do, and there's got to be a test. I'm pretty sure there is a test for competency, or maybe,
Okay.
maybe you're used to the Canadian codes, but you
Yes.
definitely don't have to start from square one. I know that. I don't know.
I think it will take at least 1 year of working in Canada, like professional experience in Canada, because the process starts with like academic qualification, and probably most schools in the US are going to be academically qualified in Canada. So once you get that kind of checked off the list, the next thing is that 1 year of Canadian experience, and then you register as a engineer in training. And I think you can argue that the amount of years that you've worked in the industry, like when you're writing your reports, can count. So you would
Hmm.
reference like the professionals that you've worked with, and maybe you need 4 years worth of reports on work that you've done. So I know for me, the big part of the time I spent doing my research, working on my PhD, counted as professional experience because my advisor, yeah, he's a professional engineer. So the work we did and all the design we did in the lab and the testing and research counted as professional work. So that kind of helped me in this way, that
Hmm.
the amount of time I spent doing research counted as professional experience. So I think yeah, you might argue like, because professional structural work is structural engineering work, and I think there is a chance that
Okay.
you can argue that this is relevant work.
Yeah, I'm just curious because I do think that there are engineers that want to venture out, and go see if they can apply what they've learned and skills they have to other countries as well. And so that's just an interesting.
On over to Canada, where we'll welcome you with open arms. Yeah.
There you go. So you touched upon this. Maybe we can dive into this a little bit about building codes. Like, to what lengths do you guys think that your countries have adopted building codes, and are they well enforced?
Building codes in Canada. Well, there is the national building code that we follow, and I think over the last 20 years, I think they release a new edition every 5 years. So there was the 2005, 2010, 2015.
Okay.
I'm not sure if 2020 came out yet, but anyways, so that's the overall for the country, but each province has their own building code for the most part, and they will reference the national building code, but have their own amendments. So they'll say, okay, so majority of the code is the Manitoba code. It's get a copy of the national building code, and that's our code, except for these things. And then they have a bunch of amendments. So Manitoba building code actually is behind. We're still referencing 2010 because you don't have to adopt every one. You just have to adopt a certain code. So there's some changes in the 2015 code that most other provinces around the country have already, adopted. One being like there's some load combination stuff for structural engineering that they're using a certain combinations and certain factors while we're still using the previous ones. So
that makes sense.
We're leaning towards, I'm pretty sure we're in Manitoba, we're going to start adopting 2020. So we'll have a bit of a learning curve compared to other provinces because we're going to be, learning 10 years worth of new elements to the code. Wow. And also seismic. In Manitoba, there's we're not in a seismic zone. So the old code there was a clause, or at least in the Manitoba Building Code, the 2010 version, there's a clause that says you don't have to take into account seismic in your design if there's a number is less than a certain thing. But the new code, I'm pretty sure they make you check it no matter what.
Wow.
That's one thing that we're going to have to do because of this new code.
Interesting. Yeah, I was curious about that. And Mostafa, do you know anything about that in Egypt? What codes they're using? Are they well adopted? Are they using them?
That's a very interesting question, because I think the Middle East now has the tallest building in the world in Dubai, and I know Saudi Arabia is planning to steal that title. They're building an even taller tower. So
Burj
I think
Khalifa,
it's very
right?
Kingdom.
Burj Khalifa. Yeah, that's the one in Dubai, and the Kingdom Tower. I think that's it was supposed to be finished this year, but I'm not sure with the coronavirus and all the things that is happening around the world, it might delay it a little bit. So the interesting experience is I know when I was working in Dubai in 2005, the city was adopting international standards. So the American standards, they were widely accepted. Design the entire project according to the American standards, and they are very good, well-developed standards, in terms of concrete design code, or even testing specifications. And it was for me very interesting. I studied undergrad mainly the Egyptian standards, which are very close, very similar, I find, to the British code, the British standards. One of the main differences that I still remember, the Egyptian standards and the British, they test the concrete strength by testing a cube specimen. In Canada and the States, we test a cylinder. So there's just little differences like that. The factors of safety are a little bit different. Each country would kind of decide based on the practice of the industry in the country. But it's widely accepted that international codes, especially like in countries like Saudi Arabia and in Dubai and the Emirates, where they have like these super big projects and where they're literally pushing the boundaries. Like when you're building the tallest building in the world, there are a whole set of challenges that you're going to be solving for that first time. I remember one of the challenges they faced was you need very high strength concrete. Like the high strength concrete I've used was like about 70 MPa. That's metric. I think in pounds that's like I think in metric like maybe 4,000 psi
PSI,
or something. Yeah, that's
probably
that's
higher than that.
More
that,
than
yeah,
that.
that's the 40. That's
Probably
the
like 8,000 psi or something.
Yeah, in
so
the
probably
States we use. I've also looked into ultra high strength concrete, where they're putting in fibers into the concrete mix, and they're using kind of like new technologies like nanotubes and stuff like that to really boost the strength of the concrete up to crazy amounts of compressive strength. So
and, and,
that would be interesting to know what they're using for that stuff.
Mhm.
and it's interesting when you push it that far, the code equations that predict like the modulus of elasticity and the stiffness of concrete no longer kind of match the predictions. So you need to kind of work on your own testing and
Wow.
monitor the stiffness of the structure. Is it according to the design or not? So yeah, I think it's very interesting when you're trying to build something that is a little bit out of the norm, then you might need to resort to like an international code or international standards, and the local standards might not be enough.
Yeah, that makes sense. So it sounds like no matter where you go, you got to do some homework on standards. Everyone's going to have to do something like that to research what you're getting into and what really is
Yeah,
applicable to your case. That sounds
yeah.
fascinating. I'd like to know personally from you guys, like, what's a favorite project that you've worked on yourselves? So, Noah, why don't you go first?
Uh, let's see. Let's see. One of my favorite ones, and I've mentioned it before. If you end up on our website, I think I talk about it. But it was a restaurant, it was a local restaurant in Winnipeg that was pretty popular, but then I guess it wasn't keeping up with the time. So the owner tried to change things up, and he turned his restaurant into a microbrewery.
Mm,
And so I was involved with like the whole design and retrofitting of the restaurant to now accommodate like huge tanks of beer and all the hops and all the other stuff that goes into making a brewery and making beer. That's super
nice.
heavy. Like this stuff was like the floor was not designed. The floor was designed for people sitting, having some chicken or steak, not for these huge tanks. So we had to do lots of reinforcing to the structure, new foundations. I remember pouring the piles inside of an actual building. That was pretty neat to see them get in there and do that. And
That's
we
cool.
tore out the floor. We put in new, heavy beams. Uh, there was other things like they needed blast control on the windows. So they
Really?
wanted the restaurant to be able to see into the brewery, so the windows were super high strength. We
Hmm.
had to do some special design there. And now that that's done, I mean, it was a smaller job, but that's a really cool project for me because now it's in my area. I go there with friends all the time, and I point things out and I say, "Hey, so that beam I designed, or the floor you're sitting on right now, this is a solid floor. It's not going anywhere." So
Very memorable. That's awesome.
yeah, that
That's
and then
great.
and also me and Mostafa, he's not working with me anymore, but we did a few high-rise projects together at the firm. We worked as a team together. I was more of the overall sort of project manager and design of overall components, but Mostafa was always the one doing the modeling. He's really experienced in modeling high-rise buildings. So he would give me information from there. We worked together to solve things, make the building stiffer, and take the loads down to the foundation. So really enjoyed
Very
doing
cool.
that when he was around.
Well, how
Always
about you,
fun.
Mustafa?
I have to say, one of the really interesting projects I got a chance to work on is this tall building in the city of Mecca in Saudi Arabia. It's very famous for the clock. It has a clock, a big, huge clock on top of it. It's called the Mecca Royal Clock.
Hmm.
And that central tower is like 120 floors. I think it's one of the top 10 tallest buildings in the world. And the whole project was very interesting challenge because it was where it was the site where the project was going to be built. There was like a big hill, and they decided that they needed to remove a big chunk of it, like huge amounts of demolishing, like the rock and stabilizing the soil and all the slopes and the rocks. So it was yeah, a very expensive project. I remember it for like the wind tunnel testing that was needed to assign the wind loads, and I did the finite element modeling and work with like the loads from the wind tunnel and put seismic loads and try to get the walls to work and design all these elements. That was a very interesting project. And one of the elements that I still remember to this day was a transfer, like for the load transfer for the typical floors to kind of reach the foundation. Uh, the the footprint of the structure intersects with like a highway. There is like
Hmm.
two big traffic lanes at the bottom of it. So it created these huge spans, and eventually the
Maybe we
solution
lost
was
him.
like
Say
very
that
thick
I mentioned before.
concrete slab,
Can
transfer
you hear me?
slab, like
Yes,
five
we
meters.
got
That's
you.
like 3 floors or something like that.
Wow.
It's it was very interesting, reinforcing this solid concrete slab for shear with like stirrups and heavy layers of reinforcing. That was a project in itself. So
Um,
very cool stuff.
Noah, did you know about that? Did you know about Mostafa's project that he really liked working on?
Yeah, I remember. He's definitely showed me some stuff about it. And
Oh, that's great.
sometimes we're comparing our projects to that one, but nothing really compares to that.
That sounds awesome. Well, hey, let's jump into just some really quick answers I'd like to ask you guys, and you can both answer them really quickly. But like, what's an obstacle that you faced when you became a civil engineer? Noah, you want to go first?
Okay. One of the obstacles for me would probably be that I mentioned before, I didn't really have any connections to the engineering industry. So
Okay.
I was sort of on my own, like I had some people in engineering class that I was friends with, but I didn't know, other than the professors in my class, I didn't know anyone that I can go to for advice or help. So I sort of had to do a lot of that on my own,
Okay.
figure things out. So I would attend some associations or the odd conference or, lunch and learn, try getting, ahead of the game. It took a while. And even once I started, finally got the job I wanted, just being able to uh, learn what it's like to be an engineer in the consulting industry, that took me a while. I know my learning curve started pretty slow, or at least my trajectory, it took me a while to understand how things work. When you're constructing a building or when you're doing the design, if you have no experience, like some of the other people in my office, or like they would have had experience, I don't know when I'm designing a concrete beam or a steel connection, like, is this actually constructible? So that was one challenge for me that took me a few years to really wrap my head around, how, if a beam is this big, how much rebar can actually fit in that, or if there's this obstacle in this way or this architectural element, even if this beam size works or this span works, it may not actually work for the architect. So just figuring out how things come together and being able to work as a team and realizing that it's not just the structure that's being built, it's so much more that's involved.
Very
And
good.
the same goes for any other area of civil engineering. It's not just our work. There's other disciplines that need to have input.
Very good. And Mostafa, what's an obstacle you faced when you became a civil engineer?
For me, I would say too much schoolwork. The program I did undergrad was like very heavy on courses. There was like a whole bunch of courses. Like I remember the third year undergrad, there was like a lot of projects and structure drawings and a whole bunch of assignments and things like that. But by the end of my undergrad, I was exhausted. I was ready to like not touch like school again. But it's funny because I ended up going back for my master's and PhD. So yeah, I
Yeah,
guess
that's a
once you
lot of
go through
schooling.
that, yeah, that's a lot of school. You're right.
Very cool. Well, I want to be respectful of you guys' time. Let's jump into, let's talk about a resource, either one of your own or something you wanted to share with the CEA community that you could share with us. So I know you guys have your own website. Maybe you could chat about that.
Sure, sure. So a resource that we would recommend all your listeners and viewers to check out is our website. So on the side of working as consulting engineers and as Mostafa as a professor, we started this thing in our free time, this sort of small business or this platform called Structural Engineering Basics. So if you're a civil engineering, either a student or a new grad interested in getting into structural engineering, or if you just started off as a structural engineering intern and you want to know what it's like having a bit more experience under your belt and how other engineers approach structural engineering, definitely a good resource to check out. So on our website we have free blogs, we've got videos, we also have a YouTube channel, but our main thing is we have an online course that we created, and it teaches people about the basics of structural engineering. It's great for students, it's great for new grads, like I mentioned. We also have a lot of students in our course who are contractors, people building the structures. They should definitely know some background on structural engineering. It'll save them time if they know about how connections work, how loads are transferred. There's plenty of stuff. There's I think we have 13 hours worth of content in our course. In the course, you also get access to us. So we have office hours where you can ask us questions, go over some of the assignments, quizzes, or anything. Just talk about what it's like, what structural engineering is where you are in the world, because we have people all over the world in our course, which is awesome because we pick each other's brain about different things, what a job site's like, the differences and stuff like that. So I know we have people in Mostafa's end of the world. We have Japan, New Zealand, India, Brazil, all over the US, all over the Canada, and it applies to everyone. So if you're in the States, yeah, we made it in Canada, but it's more the universal, it's the big picture of structural engineering. So we're not going into technical stuff or units. We might mention some metric Canadian units, but it really won't deter you from or prevent you from getting the full experience of the course.
Hey, that brings up a question I have. Did they teach you U.S. units in school when you go through school? Do you have to learn those too?
No, I mean, you learn some in high school maybe, and you learn fractions in elementary school, so we know how to use inches, feet, and stuff. But most of it is for us is kilograms, kilonewtons, meters, stuff like that.
We have to learn both, and then
Yeah.
when you actually get in the industry, it definitely gears toward the U.S. system of units for structural engineers for sure. But any other industry, yeah, you're using both. So
right now, as an engineer, I learned a lot of that on the job. So PSF, PSI,
cool.
it all depends on either
conversions.
Yeah, if the client wants to do the drawings in metric or imperial, if they want to do imperial, then you got to do everything. Yeah, obviously in feet, all the dimensions. You have to put your loads in.
That's cool. I was just curious.
Yeah.
Units always come up.
Yeah.
So Mostafa, do you have anything to add on this resource or anything else outside of it that you want to talk about?
As Noah mentioned, Structural Engineering Basics is an online platform, helps people understand the basics of structural engineering. The website is structuralengineeringbasics.com. And you can, there's lots of free content and information that you can find helpful. And you can actually sign up for a free intro section to the course if you want to check it out, see if the content is something that you're interested in. And we're very fortunate actually by the feedback we got from people that we've helped. Actually, we have a contractor from the United States. He used our program to kind of teach and train his staff for the construction work that they do, and a project manager from Japan. He found himself like responsible for developing structures, and he's leading teams of professionals with structural engineers. And he thought like, hey, I need to learn about the basics, and yeah, like we got very positive feedback from the people that we've helped. So yeah, check it out. And you can reach us at info@structuralengineeringbasics.com. And yeah, we'd love to get in touch.
That's great. And we set up a special link for everybody listening. If you go check out structuralengineeringbasics.com/CEA, you'll be taken to kind of a page where it describes each course, and you can check out which course that you would like to check out yourself. So it's a special link. Definitely go check it out, structuralengineeringbasics.com/CEA, to go check that out. I like to end with this question. It's kind of a fun one, but if you had all the resources in the world, what's something that you would like to be a part of as a civil engineer?
For me, maybe I always liked watching that show, Mega Projects. I think it was on Discovery Channel. So I think it would be like working on a mega project, like world's tallest building or a massive dam, but being able to collaborate with engineers or a project team from all over the world. Because I know those projects, you'll see the architects from the States, and the lead contracting company could be from, United Arab Emirates, and you could have mechanical engineers from this country. And so I think that would be awesome.
That would be cool.
To work on a team with people who can bring, their talents and expertise from different areas around the world.
Very cool. And Mostafa, how about you?
I definitely agree. Mega projects are really cool and fun to work on. But there's actually this thing that I'm really interested in, and it's kind of like I think it's still developing, the industry of like building homes. Like, I don't know if you heard about this, like 3D printed homes or like pre-assembled homes. It's something like, to me, that's the logic way of like building homes. Like you produce them, mass produce them, and ship them to the site, and then assemble them, and they're ready, and you can build them very quickly. But obviously, there are going to be a lot of challenges to do that, and I think the regulations as well, and the standards and safety and things like that. So I think in concept, it's a pretty cool concept. It will obviously take a lot of resources to develop it and change the way we build our homes. But I think this could be a reality. This could be a reality.
Make it happen
someday.
Yeah, I think it's happening already, right? There's some of that's going on. That's really cool. Well, guys, thanks for jumping on the show. I think it's been fun to learn about internationally professional engineers, the requirements that you go through, and everything along with that. Fun to share your resource as well. So, and you've left your email address so people can get a hold of you that way if they want to reach out more to you. So I really appreciate you guys jumping on.
Anytime. We'd love to be back.
Absolutely.
All right.
Thanks for having us.
Bye. Here we go. Zoom. And it's going to be a fun international podcast flavor. It's going to be good. International flair. You know what I'm saying?